In this chapter, in cis1103, this is week 7, we will discuss about the cabling or media for the network. Okay. We all know that computers and network, they only understand binary or digits, digital numbers or binary digits, zeros and ones. So everything at the end should be converted into 0 or 1. This digit is called bit. If I have 8 digits, it's called a byte. Okay. So the data is converted into binary numbers. Then it should be converted into signal so that you can transmit it over the media or the cable. We have some examples of media like what? We have copper, fiber optic, electromagnetic waves through the air also. So what is a signal? A signal consists of electrical or optical patterns that are transmitted from one connected device to another. And we have 3 common methods of signal transmission. This can be electrical signals, and here the data is transmitted as electrical pulses on a copper wire, or optical signals. The data is by converting the electrical signals into light pulses. It will be light pulse, on, off, or light is traveling. Or we have wireless signal through the air or through the space. Bandwidth. It is the capacity of a medium to carry data. Digital bandwidth measures the amount of data that can flow from one place to another in a given amount of time. So it's not the actual speed, it's how much data can travel at this per second. Okay. So the unit for bandwidth is bits per second or kilobytes per second or kilobits per second. If you want to transmit text only, then you need lower bandwidth. If you want to transmit music, photos, videos, then you need higher bandwidth. When the bandwidth is too low for the application, you will find that your system is slow because you have less bandwidth. So bits per second, this is the fundamental unit of bandwidth. Then we have kilobits per second, that's 1000 bit. Mega, 1000, 1 million bit. Gigabits is 10 to the power 9 bits per second. Terabit is 10 to the power 12 bits per second. You have to know these units, please. Any questions? So throughput is usually less than the bandwidth. Throughput is the actual measure of the transfer of bits across the media over a given period of time. Due to the number of factors, throughput does not usually match the bandwidth because the amount of data being sent and received over the connection, the types of data being transmitted, the latency created by the network devices. Okay, these are all affecting the throughput. We have another term which is latency. It is the amount of time, including delays, for data to travel from one given point to another. It is called latency. So here, if this computer is sending a packet to the server, you see it's taking 800 milliseconds. And then to come back, it's taking another 900 milliseconds. So for this PC, the latency is 800 plus 900. Okay. Here we have bandwidth. You see the bandwidth, the throughput is less. transmission flows. These are things that are affecting our transmission, such as noise. Noise is any undesirable influence, degrading or distorting signal. And we measure noise in decibel. dB is decibel. There are two common sources of noise: EMI, electromagnetic interference. It is caused by the motors, power lines, televisions, copier, fluorescent, anything electrical. And there is the crosstalk. It occurs when the signal on one wire infringes on adjacent wire. I have two wires. The signal goes from here to the second wire. This is called crosstalk. So let me just maximize this. Here we have a pure digital signal is transmitted, number one. On the medium, there is an interference. So the interference is causing, this is the interference signal. Then we combine them together, we get this signal. So this signal is distorted. If I want to read it again, I will get some errors. Like this bit here is error. Originally it was 0, but because of the noise, it went up. It went up. So the receiver read it as 1. So I got error. We have the attenuation. The attenuation happens when the signal is traveling. The longer it travels, it will become weaker. This is like everything in life. When it goes traveling, after some distance, it becomes weak. We call this attenuation. So how do we overcome this problem? How do we solve it? By using repeater. The repeater regenerates a digital signal in its original form and removes the noise. Please listen to this. The distance that a signal can travel in a UTB cable is 100 meters. You can write it down. Maybe it's not written here, but sometimes we ask it in the exam. 300 meters is the maximum length for a UTB cable. If you need to go more, then you need to put a repeater. Okay? Network media or cables, we have physical, which is wired, or wireless. Physical media use wire, cable, and other tangible materials to send communication signals. So they are physical materials, such as twisted pair, coax cable, fiber optic cable. And usually we use them for the underground between buildings. The twisted pair. There are two types of twisted pair. By the way, twisted pair is very popular because it's not expensive. It's easy to use. Okay, it consists of one or more pairs of insulated wires. We will show these cables, inshallah, in the lab. So you look here, we have twisted two wires together. Twisted pair cable uses pulses of electricity to transmit data. What are the disadvantages of twisted pair? Data transmission over copper cable is sensitive to EMI. So that's a drawback. Also, crosstalk. It is subjectable to crosstalk. It's not immune to crosstalk. Especially if the cables are bonded together for long distance. Two types of twisted pair, shielded and unshielded. The shielded twisted pair, the advantage of the shielding is shielding acts as a barrier to external electromagnetic forces. However, the shielding must be grounded. And to have good quality of the shield, we have to take care of these factors: level and type of environmental noise, thickness and material used for the shield, grounding, how you are doing the grounding, proper grounding, symmetry and consistency of the shielding. And the shielding all over the cable is the same thickness. Okay. Newer type of cables such as Cat8 incorporate more sophisticated shielding materials and more tightly twisted wires, so it gives higher bandwidths. Okay, that's Cat8. It's competing with fiber. This is how a Cat8 cable looks like. You see this one? This is a Cat8 cable. UTB, unshielded twisted pair, that's the normal cable you find everywhere. You can see here at the back of this computer. So it does not have a shield or does not have additional shielding on the outside. So it's less expensive, but it is less resistant to noise than STP. And UTP is more popular. But nowadays, because shielded twisted pair become less expensive than before, also shielded twisted pair is becoming increasingly used. This is a very good comparison between the type of UTB cables. We have Cat3. This is suitable for Ethernet LANs up to Cat7. You see the speed in Cat7, 10 gigabits. In Cat3, it was only 10 megabits. So you have to know the differences, please. Okay. Cat6, you can get 1 giga. Cat6 manufactures with higher standards than Cat5, so it has more twists to prevent EMI and RFI from outside sources. So it is more immune to interference because it has more twists. Any questions? So if we want to compare STP and UTP, throughput, STP has more throughput. STP and UTP can transmit the same rates for the throughput. But the STP and UTP vary in cost. STP is more expensive. Connector, they both use RJ45 or Jack45. STP is more noise resistant. Size and scalability. The maximum segment length for both is 100 meters, as I told you. Okay. If you need to go more, then you need to put a repeater. Some categories of STP require shorter segments even to achieve maximum throughput. Twisted pair operation. Twisted pair, if you look at this diagram here, you can see this is the connector, and you see the wires coming to the connector. So we have green, striped green, blue, striped blue, like this. They are connected to the adapter. Okay, and we have two standards for the connection. We have T568A and T56B. If I want to use one of them, I should use it at both sides, both ends. Okay. So you have to be sure about that. So if I am using this wiring scheme, these colors, I should use it for all over my network or my project. So here you have a twisted pair operation. The cable is connected to your network cards, okay, from on this device, on the receiver and on the sender, okay. So these cables are designed so that the data can travel through them. So they can be used to transmit and to receive. When two unlike devices are directly connected using a UTB cable, it is important that the transmit function and the receive function on each end of the cable are reversed. If I am connecting computer to computer, I should reverse the colors. We call this cable cross cable, because I am connecting the same computer from one side to the other side. So we reverse the wires. So the cable is called cross. So the sender here is connected to the receiver here, and the sender here is connected to the receiver on the other side. Cross cable. Here they told you, you don't need to remember the name of the wiring, but if it is, you are going green to green, they are telling you you are using the TIA EIA 56BA straight through wiring. So here you have the transmitter and the receiver, they are using the same color. Striped green, striped green. So this is a straight through cable. Why? Because this is going from PC to switch. If it is PC to PC, it should be reversed. So a crossover cable is used when connecting two similar devices, such as PC to PC, switch to switch, router to router, and a PC to a router. Coaxial cable, it is the thick cable. This is the old one. It started being used in 1980s. But nowadays we use other cables. We use UTB, twisted pairs, fiber. However, it's still used for some cable internet, cable TV, and some multimedia devices. So it has a central core metal. This is the one, central core. Okay. Then it has a dielectric insulator, azle. Okay. Then it has a metallic shield. Then you have also another plastic jacket. Okay. I think if you used to see these cables in the receiver of your TV, before the cable TV, you were having these connectors. We have some of them in the lab also. Fiber optic cable, they transmit data using pulses of light. It is constructed of either glass or plastic, and it is very immune to AMI and RFI because it's light. Parts of the fiber optic cable are, we have the jacket. This is the jacket outside. The jacket is usually made of a PVC, like plastic, for protection. Then we have a strengthening material, surrounds the buffer. This is the material for strengthening, taqwiyah. Okay, this is the buffer. And then we have the cladding that will reflect. Then we have the core. This is how it looks like. This is a fiber optic cable, as you can see here. Any questions? What are the advantages of fiber optic? It is high throughput, extremely high throughput, very high noise resistance. It's secure or excellent security. And also it can carry signal for long distances. The disadvantages, it's more expensive. Also, it requires special equipment to install. We call the handling of the fiber slicing. When you connect the connector or we connect fiber optic cable, we call this slicing. And it needs training. Not any technician can do slicing. They have to do proper training, they get certification to do slicing. And they make good money. We have also power over Ethernet, and this is defined by IEEE 802.3AF standard. It is a method for supplying electrical power over twisted pair Ethernet. Okay? The amount of power is not very high. It is only 15.4 watt for a standard PoE device and 25.5 for the newer PoE device. You just need it to power your device. Okay? And they specify two types of devices. PSE, power sourcing equipment. This is the device that is giving the power. And the other one is PDs, powered devices. You need Cat 5 or higher. So you cannot use it on Cat 3. The PSE sourcing device first determine whether a node is PoE capable or not. On networks that demands PoE but don't have PoE capable equipment, you should add an adapter. Okay? And if you can see some switches or some cameras, you know, they don't have a power cable, right? So where they are getting the power? They are getting the power from the network cable, from the switch. Because the switch is a PSE device, and that type of device is PD. This is a diagram here. You have a PoE security camera, okay? And this is a PoE switch. If I have here a non-PoE switch, I need to add an adapter, okay? So this is what they are trying to tell you. Any questions? So this is the last slide on this chapter. These are the references.